Hey guys, Mr. T here, another video. This one's about parallel box plots. So last time we talked about what box plots were and how to draw them. Now, if you draw two box plots, two or more box plots for two or more different data sets, and draw them parallel to each other on the same scale, that allows you to make easy visual comparisons between them, and you can come to really quick conclusions. So hopefully this video is going to be an example of how that works and what conclusion you can make about two different data sets. So when you are doing parallel box plots, because you're dealing with multiple different data sets, you have to make sure that you clearly label the box plots with the data sets that they involve. I'm not going to take the time to draw out the data sets here. We're just going to look at parallel box plots and see what conclusions we can make about them. So in this example here, the time taken to have an effect is measured for two different drugs, drugs 1 and 2. The data is represented in the following parallel box plot, and we're going to try to identify if one of the drugs acts faster than the other. So looking at this, we don't know what the data is. We can come to some conclusions about it. So the minimum for drug 1, the minimum time for drug 1 was 7 seconds. The maximum time was 12 seconds. The minimum time for drug 5 was drug 2 was 5. The minimum time for the maximum time for drug 2 was 21. So straight away you can see that drug 2 is a lot more spread out, a lot less consistent than drug 1. So that's one conclusion you can make. So firstly, drug 1, much smaller range, more consistent. Time for effect. So that's just a measure of consistency there. We're ignoring what the numbers of the consistency was. We're just looking at the range. It's more consistent anyway. What else can we conclude from here? The median of drug 1 is lower than the median of drug 2. So drug 1 median lower. So faster effect based on median only. What else can we conclude here? Interquartile range is only 2 for drug 1, whereas interquartile range here is from 8 to 12.5, so it's going to be 4.5. So drug 1, IQR, smaller. Again, more consistent. It's telling you the same thing as before with the range, more consistent. Middle 50% of data. More consistent based on the different ranges. What else can we talk about? So those are the main points here. We can deduce from these that drug 1 is more consistently faster to have an effect than drug 2. So because it's less spread out, it's more consistent. The data, the times to have an effect are less spread out, and because of the median, they are lower. So more consistently lower than drug 2. We could be pretty confident that drug 1 acts faster than drug 2. But I just wanted to go over some other conclusions that you can make here. Because of where the box is and where that lower whisk is there, we can conclude that this represents 75% of the drug 1 data. This here, I'll use red here, this here is 50% of drug 2. So what we can conclude here is 75% of drug 1 action times were less than or equal to the fastest 50% of drug 2 action times. What am I saying there? 3/4 of drug 1's times were faster than the fastest 50% of drug 2. So that's another deeper way of you saying that drug 1 acts faster. In fact, if we take that further, 100% of the data for drug 1 is still less than 75% of the drug 2 data. So going further than that, if you wanted to waffle on a bit or talk with more detail, 100% all the drug 1 times were still less than the fastest 75% of drug 2 action times. So if you're looking at ways to sort of hammer the point home and say that drug 1 acts faster than drug 2, we already used the median. That's the very first thing. The middle of the data is lower, so it's faster. We then argued that it's more consistent because the ranges are less, both interquartile and the range overall, so it's more consistently faster. And then you went further on by stating different percentages. So that's the only conclusions that you can come to. That's the only stuff that you can talk about when you are comparing box plots, is these percentages. That's probably the most detailed that you can go. And then the position of the center and the spread. You can only talk about those things. There's not really anything else that you can conclude from box and whisker plots and parallel box plots, okay? So hopefully that helps you out, and I'll see you in the next video.